In this section, we want to just look at a combination of a lot of different kinds of factoring problems. Here's our first one. I have x squared minus 81. I have two terms. It's the difference of two squares, x squared and 81, which is 9 squared. So I know that's going to factor into the sum, x plus 9 times the difference, x minus 9. So the difference of two squares always factors into the sum times the difference. Our next problem here is x squared plus 49. That's the sum of two squares. The sum of two squares with real numbers never factors, so we call that a prime polynomial, meaning that it's factored down as far as it can go over the real numbers. So difference of two squares always factors. The sum of two squares never factors. Here's our next one. X cubed minus x squared. It's a difference of, well, one's a cube and one's a square. So now the first thing I want to do when I look at a factoring problem like this is look for a greatest common factor. I see that x squared is a factor of each term, so I'll factor that out. Just with the distributive property, what's left in the first term when I factor out x squared is x. What's left in the second term when I factor out x squared is just 1. X minus 1 doesn't factor any further, so this is all the farther I'm going to go with this problem, x squared times x minus 1. So I factored there by taking out the greatest common factor. Problem 4, I have the difference of two cubes. So this looks to me like 3 cubed minus r cubed. So the difference of two cubes always factors, as does the sum of two cubes. So to factor the difference of two cubes, I use my formula. I have 3 minus r. That's times the square of this, which is 9. Next, it's always a sign that differs from this one. And then I multiply these two together, 3r, and I always add on the square of the last term, r squared. So remember, when I factor the sum or difference of two cubes, I always use that formula which I've memorized. So if this seemed a little confusing to you, it's just simply because you haven't memorized the formula. Here's the next problem. Problem 5 is a trinomial. I notice that there's no greatest common factor other than 1 for these three terms. Trinomial, I'll try factoring by kind of my trial and error method. Let's try 3x and 4x, because 3x times 4x is 12x, and then my 2, if I put the 2 here and the 1 here, inside I have 8x, outside I have 3x. 8x plus 3x is going to give me 11x. I need a negative sign, so I'll make both of them negative. Let's check. 3x times 4x, 12x squared. Negative 2 times negative 1, positive 2. Inside is negative 8x. Outside is negative 3x. And sure enough, those two add up to negative 11x. So a trinomial, no greatest common factors other than 1, so I factor this by trial and error. The next problem is also a trinomial, but it has a greatest common factor. Let's take a look. I have 100x squared minus 100x minus 600. So I see that I have 100 common to each term. Let's factor that out to start with. So I have 100 times x squared minus x minus 6. Now this trinomial doesn't have any greatest common factors other than 1. I'll factor it into the product of two binomials. Each of them has a first term of x, so that x times x is x squared. The last terms that go here need to multiply and give me negative 6 and add and give me negative 1. So I'm going to say, how about negative 3 and positive 2? Negative 3x inside, outside is positive 2x. They add up to negative 1x, and negative 3 times positive 2 is negative 6. So here's the complete factorization of this trinomial. One factor is 100, next factor x minus 3, next factor x plus 2. One last problem. Here I have 4 terms, and I see no greatest common factor other than the number of 1 for all the terms. So this is the situation where I want to try to factor by grouping. So I'll group these first two together, and I'll take out whatever greatest common factor they have, which is x squared. So I factor out x squared, and I get x squared times x plus 5. Put my equal sign in. Now, here, these two terms, I want to put those together. If I factor out a 9, which they have in common, I'll be left with minus x minus 5. So what I'll do instead is factor out a negative 9. When I factor negative 9 from this term, what's left is x. When I factor negative 9 from this term, what's left is 5. Now I see I have two big terms, this one and this one, each of which has x plus 5 common. I'll factor it out, x plus 5. what's left is x squared minus 9. Now at this point I have to check my factors. X plus 5 is prime. It doesn't factor any further. But x squared minus 9 is the difference of two squares, x squared and 3 squared. So I have to continue factoring until I can't factor any further. X plus 5 times x plus 3 times x minus 3. So there's the complete factorization for this polynomial, which has 4 terms. I used my factoring by grouping sort of the distributive property sort of twice to get down here, and then I check and see, well, look, that factor factors again, so I have to go ahead and do that. So here's the complete factorization for that polynomial, and a little look at a lot of different kinds of factoring.